Electromagnetic Field 2024 is fast approaching, and for next year I'm going to make an unusual electric vehicle. If you've not discovered EMF Camp yet, it's like a long weekend of geeky camping in the UK where technical people get together and have some fun. There's a link below. It's going to have a seat and a single fat back wheel at the front, with two separately driven track units at the rear. Each track unit's going to have its own speed controller, and I'm going to connect these to a custom controller that will let me adjust the speed of each track as the steering angle is increased. So there's a bit of Arduino stuff later. The first task is to make the track unit, so here goes. Right, so here's the track as I'm sort of seeing it at the moment. I'm sure it's going to change from this design, but I've got to start somewhere. The most important thing I've got to get right before I can do anything else are the track drive units, because the track units that I got from AliExpress have got a splined drive, and that means that I'm going to have to create my own drive shaft. I've never cut a spline shaft before. I intend to do it on the milling machine with a rotary table, but I've also got a rotary table buddy that I'm going to use to help me automate the cutting of these splines. But if I can't make this part, then I can't continue with the project, so this is the first place to start. Here's a close-up of the track unit, and you can quite easily see the spline section on the drive sprocket. I'm marking out the section that's going to have the splines cut in them here, using the traditional method of vernier calipers in combination with die chem. The drive shaft is supported by pillar block bearings at each end, so I have to turn this section down. Here I'm marking out the other end of the spline section on the shaft. And just a quick test fit of the pillar block bearing, that seems alright. Here's a quick demo of the rotary table buddy I created for this project. You enter the number of splines that you need, and the software calculates the number of stepper motor turns required to deliver that angle. Here I'm entering 3 splines, which gives a rotation of 120 degrees per spline. There's a link to a blog post about how I made it below. Here's the rotary table buddy on the mill, dialed in to give me 23 splines. With a 60-degree groove cutting tool I got from AliExpress, it takes about 10 minutes to make each spline. It's a bit dull to watch, so here's a hyperlapse. You can just see the buddy do its thing at the end. And so the big test, is it going to fit? Oh yeah. The highlighted parts here mount the pillow block bearings. They've each got a couple of slots in them to allow me to adjust the position of the bearings as well. The frame's 20mm box section, and I've used one of these carbide tipped saws on my crosscut miter saw. The speed needs reducing though from the wood cutting blade, so I've bought this superb quality 10 kilowatt rated Chinese speed controller. It looks great. What could possibly go wrong? Although the quality of the motor speed controller was a bit dodgy, it does actually work surprisingly well, and I was able to cut through the box section still pretty quickly, and the end results speak for themselves. And then it was onto the mill to create the slots for the pillow block bearings. The top section of the motor drive unit is just a rectangle made out of 20mm box section steel, so that should be pretty easy to get together. On a scale of poor to excellent, my welding skills would come in around laughable, I think. The highlighted sections here all need to be the same length to make sure that everything lines up, so they were the next things to cut. With the miter saw in 45 degrees mode, it was pretty easy to make these. I just had to be very careful and check that the lengths were all the same. So a quick double check to make sure everything's fitting together as it should. So after carefully checking the lengths and the angles of the diagonals, it's time for some welding. It was during this welding exercise that I realised the problem wasn't actually with the welding torch, and it might have been me. A quick rolling check with the axle in place just to make sure. And then it's time for the final welding of the track frame. This hand-latted part mounts the sprocket onto the drive shaft, and it's going to be made from some pretty thick steel turned down on the lathe. This plate's going to have a 20mm hole through it to fit onto the drive shaft, so I started off with a pretty big drill and then turned the plate down to thickness. Then I drilled holes in the plates ready for tapping. The drive shaft needs a keyway in it, so I milled a 5mm slot for that. And then using a broaching tool I put a matching keyway in the drive plate. There's a gap here in between the pillow block bearing and the drive sprocket that's going to need filling. For this I'm just going to part off a bit of pipe that will just fit over the drive shaft and breach the gap quite nicely. This is a piece of tube from what will become the frame, parting off skills acquired from Blondieacs. Before I go any further, I thought it'd be a good idea to try these 2kW BDLC motors that I got from AliExpress. They come with a motor controller and a throttle that's got reverse and speed switches on it. Quick check shows the motor running at 4000 RPM. No idea how fast that's going to mean on the real thing. Each motor is going to be mounted using 2 steel plates. The smaller of these will move forwards and backwards to let me change the chain tension, and the others will let me move it side to side to align the sprockets with the drive shaft. There's also going to need to be a bar going across here so I can fit the studs to mount the plates on. I thought I'd better check the design of these plates before I made them out of steel by laser cutting them out of 3mm MDF. And it's a good job I did check them because I had managed to get the sprockets misaligned, so try again. So now I'm faced with the task of cutting multiple pieces out of 4mm sheet steel. I thought I'd try this Bonco plasma cutter that I bought quite some time ago, but I wasn't impressed with the results. This one's going in the bin. Next it was turning the jigsaw, but although this gave me a nice clean cut, it was going to take me about 4 weeks to cut out what I needed. So I ended up where I really should have started, using the angle grinder. Unfortunately I wasn't looking where the sparks were going and I managed to burn a hole in my jacket, and then of course thinking of that I almost had a runaway angle grinder. With the blanks cut out for the mounting plates, I cut out a paper layout from the CAD system, bit of spray mount, gets this stuck down to the blank, and then using an optical centre punch I punched some pretty good centres on the holes ready for drilling. So with the blanks cut out and some slots milled, it was time to tap the holes where these studs are going to fit. The studs are all cut by hand from 8mm threaded rod, and these were then welded into place. It's time for a test fit. It's not looking too bad, quite pleased with the way that's turned out, and now it's time to put it on the frame. Before that though, I need to weld the cross beam in place on the track drive unit. This is going to be the mount for the studs that's going to hold the bottom plate in place. Unfortunately, I'd forgotten to check the dimensions of this cross beam. So I cut myself a thinner cross beam from some leftover steel plate and quickly got that welded in place. With the workpiece securely held down, I drilled the holes ready for tapping. All the holes for the motor mount are tapped to M8, and with the studs put in place, I welded them to secure them. Being able to move the plate from side to side will allow me to align the drive sprockets. With everything made up, I'm ready to bolt it all together and give it a test. The motor and the drive shaft sprockets are T8. I think I'll probably need to put an idler wheel on this, but for a quick test it's not going to be a problem. I'm pleased with the way these turned out. I learned a few skills along the way, welding was not one of them. The next video will be how I make the trike frame, so please like and subscribe. It should be ready soon. Thanks for watching, and here's a teaser.